Right, so earlier in chapter 11, we talked about parts of a circle, tangents, chords, secants, and then we just talked about some arcs, chords with that, and so on. Today, let's talk about 11.5, inscribed angles and polygons. So let's talk about an inscribed angle. We're going to start with some definitions. So an inscribed angle is an angle whose vertex is on the circle and whose side contains chords of the circle. So to the left here, I have a circle in the orange. That middle dot is the center of my circle. So an inscribed angle is a vertex who is on the circle, okay? And the sides are chords. So in my circle right now, I'm going to draw a couple chords. We know chords to be segments within a circle that go from one side to the other, okay, but do not go through my center. So here is an example of a chord. I'm actually needing 2 for this inscribed angle. So inscribed angle is where the vertex is on the circle. My vertex is right there. That part is my inscribed angle. Okay, it's made up of 2 chords, and then again, that vertex is on the circle. Okay, let's talk about intercepted arc. So an intercepted arc is an arc that lies on the interior of an inscribed angle and has endpoints on the angle. Okay, that's a whole bunch of words. Let's talk about the picture. Pictures make more sense typically. So in my picture, I'm going to use the same picture that I have here. My intercepted arc, we know arcs to be a part of the circle. It is on the circle. Okay, it's not inside the circle, it's not outside the circle, it is on the circle. So my intercepted arc is the arc that my angle opens up to. So my inscribed angle opens up to my intercepted arc. So that highlighted orange part that I just did is my intercepted arc. All right, let's talk about inscribed. So inscribed, we have a couple definitions. So an inscribed, it means all vertices of a polygon lie inside of a circle. So one thing that I use is inscribed inside. So this picture here in the red is an example of a inscribed triangle. It's where something is inside of my circle. So in this case, a triangle is inside of my circle, so it's an inscribed triangle. Okay, if a square was inside of my circle, it'd be an inscribed square. Okay, this is very similar, but a little bit opposite. A circle whose edges lie inside a circle. Again, we see that in. Okay, inscribed inside. So this is my picture in the green. So I have an inscribed circle. So right now, my bigger figure here is a polygon. Inside of that polygon, I have that circle that I just circled there. Okay, so this is an inscribed circle because the circle is inside of the bigger figure. Okay, what's very important is that the vertices have to lie on the circle. Okay, so here's my vertices here. They lie on the circle. If I talk about my green one, these all lie or touch that polygon. Okay. So inscribed is inside. Let's talk about circumscribed. So circumscribed is all vertices lie on the outside of the circle. So here's my blue picture here. So I have a circumscribed triangle. Okay, right now this looks sort of similar to this inscribed circle. My circle is inside of that figure. Well, the thing that's around it is a triangle. So it is a circumscribed triangle because a triangle is outside of that circle. Okay. We also have this one here. A circle whose edges lie outside the polygon. Again, we see that outside. This is that picture in the purple. This is a circumscribed circle because that circle is on the outside of that polygon, which is on the inside. Okay. So these get a little bit, these are a little bit tricky to get used to, but if I think of inscribed as inside and circumscribed as outside, it'll help a lot. So let's talk about theorem 11.7, measure of an inscribed angle. So if an angle is inscribed of a circle, then its measure is half the measure of the intercepted arc. Okay, so if I'm talking about the measure of angle ABD, which is this angle here, okay, it is half the measure of my arc. My arc is here, AB. It's half that measure. Let's move down to example 1. So find the measure of the inscribed angle or intercepted arc. So in A, I'm given my intercepted arc. Okay, remember that is on the circle. So my angle, NMP, which is this one here, is half of the measure of my arc, NP. So I have 1/2 the measure of NP, which you know is 100. Well, what's half of 100? 50 degrees. So this angle here is going to be 50 degrees. Okay. Let's talk about B. So right now I'm actually given my inscribed angle. I have to find my intercepted arc. So we're doing almost like the opposite. So in this case, I'm given the measure of XYZ, my angle, angle XYZ, okay, which is half of my arc ZWX, which is this green part that I want to find. Well, we know the measure of XYZ, which is 105. So I can replace that. Okay, well, I still don't have that arc by itself. Well, how do I get rid of that 1/2? Well, in order to get rid of a fraction, I'm going to multiply by the reciprocal. The reciprocal of 1/2 is 2/1, or just 2. So I'm going to multiply both sides by 2. So 105 times 2 is 210. So this green part here is 210 degrees. All right, checkpoint. So find the measure of the inscribed angle or the intercepted arc. So either one. So in this case, in number 1, I'm given my intercepted arc. So I'm going backwards. Okay, so let's use that theorem that we have. So I have my angle, BAC, is the angle that I want to find, equals half of BC. Okay, well, let's plug in what we know so far. So I don't know the measure of BAC, but I do know the measure of arc BC in the green. So I have 1/2 times 90. Well, 1/2 times 90 is 45. So the measure of BAC is 45 degrees. Okay. My suggestion is pausing the video, try the next 2, and then play it when you're ready. So in number 2, we are given my arc here, which means I have to find my angles. If you're given your arc, you're finding your angle. If you're given your angle, you're finding your arc. Okay, flip-flops a little bit. So let's set this up. So I have the measure of angle DEF, which is what I'm trying to find, that angle here, equals half of DF, arc DF. So I have, I don't know the measure of DEF, but I do know the measure of arc DF, which is 1/2 times 160. The measure of my angle should be 80 degrees. Now 3 is a little different. I'm actually given my angle. So in this case, now I have to find this green part, my arc. So we're given the measure of KMP, which is my angle, equals half of my arc. So my arc right now is KNP. Well, let's plug in what I know. I know the measure of my angle, which is 120. equals 1/2 of K and P. Okay, well, how do I get rid of that 1/2? Multiply both sides by 2, or the reciprocal of the fraction. When I multiply 120 by 2, I should get 240 as the measure of my angle. Let's move down to 11.8. So if a triangle inscribed, so inside, if a triangle inscribed in a circle is a right triangle, then the hypotenuse is a diameter of the circle. Okay, and then similarly, if a leg of a triangle inscribed in a circle is the diameter of the circle, then the triangle is a right triangle. Okay, so right now, to the right here, I have a triangle inside of my circle. So here is my triangle. I know it's a right because I see that box there. Okay, so if I know it's a right triangle, then my hypotenuse has to be the diameter. A diameter we know goes from one side to the other side of a circle, but does have to go through the center. It's the one that's very specific. Okay. Let's talk about example 2. So find the values of x and y. So because triangle ABC is inscribed in a circle and AB is the diameter, triangle ABC is a right triangle with hypotenuse AB. Therefore, x has to be 90 degrees. There's my box there. Okay, it's 90 because of the fact that x is across from my hypotenuse, which is that diameter. They are directly across from each other. Okay. Well, in a triangle, we know that my two other angles add to be 90. Okay, so to find y, I have 90 minus my 50, I should get 40 degrees. And if I add my 40, my 50, and my 90, I should get 180, which is true for all triangles, because all triangles do equal 180 degrees. All right, let's try this next checkpoint. So find the value of x and y in circle C. Okay, so right now x, I want to know, and y. So I have my diameters. So I'm going to color in all of them, all of these actually. You know, those are my diameters. Let's first label which one is my right angle. So which angle is across from that green or orange line that I just colored in? In this case, x. So this one is 90 degrees. Okay, well now I got to find y. So I know that 35 plus x plus y equals 180, right? All my angles in a triangle equal 180. So I have 35, I know x is 90, plus y equals 180. Add those together, subtract my stuff over, I should get y to be 55. This is where I suggest you pause the video, try the next two on your own, and then start again when you are ready. Let's move on. So I have x equals y equals. Okay, so right now in number 5, I have my green line. Okay, well which angle is across my green line? Well, x is not across because it touches it. This x is not across because it touches it. The only one that does not touch it is y, so that one has to be my 90. Okay, let's set up an equation. Again, all my angles in a triangle add to be 180. So let's have x plus y equals 180. X plus y plus x again equals 180, which I have down here. Let's combine like terms. I get 2x, right? I just combine those two x's, I get 2x. I know my y is 90, so I'm going to put 90 here, equals 180. Okay, subtract that 90 over, I get 2x equals 90. Divide by 2, x equals 45 degrees. Number 6, I'm going to go a little bit faster. So x equals y equals. We can see based on my picture that y is across from my diameter, or the green line, so that one has to be my 90 degrees. Let's set up my equation to solve for x. I get 60 plus x plus y equals 180. 60 plus x plus, I know my y is 90, equals 180. When I combine like terms, solve for my x, I get x to be 30 degrees. Talk about 11.9, theorem 11.9. So if a quadrilateral can be inscribed in a circle, then its opposite angles are supplementary. Supplementary, again, means 180 degrees. If the opposite angles of a quadrilateral are supplementary, then the quadrilateral can be inscribed. Okay, if they are not supplementary, it cannot be inscribed. Okay, again, we know inscribed is inside. So if I know that D and F add to be 180, then I can fit that quadrilateral inside of my circle. Same thing with E and G. They are not necessarily congruent. They could be, but not necessarily. Okay, as long as they add to be 180. Talk about example 3. So find the values of x and y. Because RSUT is inscribed in a circle, by theorem 11.9, opposite angles must be supplementary. Okay, so angle U and angle S are opposite angles, right? U and S are opposite. So I can add those two to equal 180. Well, U is Y, so I'm going to replace U with Y. S is 120, so I'm going to replace S with 120. Again, my 180 stays the same. Subtract that 120 over, I get Y to be 60. Similarly, I have angle R and angle T, which are opposite angles, which I see in my figure. Okay, R is replaced with Z. T is replaced with 80. Again, these two add to be 180 because they are opposite angles. They are supplementary. So this is 180. Subtract that 80 over, Z equals 100 degrees. And then our last few problems on the bottom here. So find the values of x and y in my circle C. Again, my opposite angles, if it's quadrilateral, my opposite angles are supplementary. So I have, what is opposite of x? 95. So I have x plus 95 equals 180. 180. Subtract my 95 over, I get x to be 85 degrees. Same thing for y. My opposite angles are 100 and y, so I have 100 plus y equals 180. Again, subtract the 100, I get y to be 80 degrees. Again, this is a good point in the video to pause, try the next two on your own, and then play again when you are ready. All right, so let's talk about x and y. So these two are across from each other. Again, that box means 90 degrees, so I have 90 plus y equals 180. So y equals 90 degrees. And then across from here, I'm going to set those two up as well. So I get 90 plus x equals 180. Subtract that 90, x also equals 90. And then lastly, number 9. So I have opposite angles. This one is a little bit trickier to see, but I can see that 50 and x are opposite of each other. So I have 50 plus x equals 180. Subtract that 50 over, I get x to be 130 degrees. And then let's talk about this side here. So 80 and y are actually opposite of each other. So 80 plus y equals 180. Subtract that 80 over, y equals 100 degrees. Okay, so in this section, we learned about intercepted arcs inscribed angles, and then inscribed polygons, and then circumscribed polygons as well.